Alright, this is lesson 27, literal equations. Today we're going to be talking about what we've been building on, using the rules of math, where we use all the different properties. And then we talked about one-step equation, two-step equations, and then multi-step equations yesterday. So today we're going to use the same concept, but we're going to apply it to formulas. A lot of times in science we use formulas, and we need to know how to manipulate the formula to what we need, right? There's like the density formula. What's the density formula? Density is equal to what? Mass divided by volume, right? Mass over volume, right? Or there's like speed. What's the speed formula? Speed is equal to? Good, right? Sometimes in science you have to be able to move the letters around to what your problem is asking. It says, what's the time if your distance is this and your speed is this? Well, you need to be able to figure out that by moving the letters around, okay? So we're going to be moving letters around in math using inverse operations. What's the inverse operation of adding? Inverse operation of subtracting? What's the inverse operation of multiplying? Inverse operation of dividing? Okay, good. So we have a bunch of inverse operations, and so we want to be able to apply them. So today's not hard, it's just the concept can be hard if you miss it, okay? So a way to think of it is, I like thinking of things in terms of food, right? So if I were making a pizza, what is a pizza in essence, okay? If I were to make pizza a math problem, well, a pizza is, if I were to make it, the pizza is the dough, right? Plus the cheese, plus the sauce, right? Would you all agree? Yeah? Okay. Now, what if I wanted to know what something else was specifically? Let's say I just wanted to know what the dough was, okay? Well, how do I get dough by itself? What do I need to do to get dough by itself? Well, I need to ask myself, SADMAP, right? Are there any subtraction signs by the dough? No. Are there any addition signs by the dough? What's being added to the dough? Cheese and sauce, right? So I could subtract cheese and sauce, and I would have to do it on the opposite side. So it'd be pizza minus cheese and sauce. And then I would simplify this, right? I would say, well, a pizza minus the cheese minus the sauce is equal to the dough. Would you all agree? Yeah, if I want a dough, I start with a pizza, take the cheese off, take the sauce off, and what am I left with? Dough. Does that make sense? Did you see how I just changed the equation around? Okay. Or here's another example. Let's say I wanted to start over and I just wanted to work with cheese. Because I like cheese a lot, so I eat cheese all the time. Cheese at night, get a string cheese, right? Raise your hand if you go to the fridge and get string cheese at night. So good. Okay. So I got cheese, right? So I want to get the cheese off the pizza. I'm starting with the pizza equation. Pizza is equal to the dough plus the cheese plus the sauce. How do I get cheese by itself? Well, I ask myself, are there any subtraction signs by cheese? No. Are there addition signs? Yeah. What's being added to cheese to get dough to get pizza? Well, dough and sauce, right? What's the opposite of adding dough and sauce? Subtracting dough and sauce, right? So I'm going to do that to the opposite side. So if I wanted cheese, I would just subtract from pizza, I would subtract dough and sauce, and I get cheese. Does that make sense? So all we're doing is moving things around. So just like we do in science, what's the density formula again, everyone? Density is equal to mass divided by volume, right? So let's say I wanted to solve this for volume. How do I get volume by itself? Well, it's in the denominator now, so I need to multiply everything by volume. So I'm going to multiply both sides by volume. So we have volume times distance, or density, is equal to mass. But I want volume by itself, so I'm going to still have to divide both sides by density. And then I figure out that volume is really equal to mass over density. You see that? Do y'all see that? Okay, so that's the big idea. We're moving letters around. That's all we're doing today. Okay? Raise your hand if in science you moved letters around before in your class, in your formulas. Okay. Yeah. So this concept is kind of hard to deal with, but if you understand, it's really important. And once you get good at it, you're going to really use it in science, and you won't get stuck. Okay. Okay. So here are the steps. If you're on the video, you should pause. And here's a formula, the vocabulary on the word formula. If you could write this down for me, please, in your notes. going to show you a couple problems here, so just watch. So this is the distance formula. Distance is equal to rate times time, okay? And we want to solve for r. So the first thing when I'm wanting to get r by itself, I want to look at what side of the fence is r in. R is on the right side. So then I ask myself, I'm going to use SADMAP just like before. Are there any subtraction signs or anything being subtracted from r? No. Is there anything being added to r? No. Is there anything being divided by r? No. Anything being multiplied by r? Yeah, what's being multiplied by r? T, right? So then I ask myself, what's the opposite of multiplying by t? Dividing by t. So I'm going to divide both sides by t. So we have distance over time is equal to the rate, right? Now we have r by itself. We solve for r. It's isolated. Now, remember yesterday, what was the property where we flipped the sides? What was that property called again? Symmetric property, right? Good. So we're going to put r is equal to distance over time. Okay? We've just solved for rate. Okay? Or, yeah. Yep. We just solved for r, which is rate. Does that make sense? So again, what did I do? Start off with the original problem. I figured out what side of the equation the r was on. I wanted to ask myself about SADMAP to get everything else out of to the opposite side. That's called isolating the variable, making it by itself. We isolated the variable on one side of the equation, r, and then I used the symmetric property. Because I always like running my variables first and then the equation after, or the formula after. Okay, number 2 is a little bit more difficult. It says a times y plus 1 is equal to b. Solve for y. I first ask myself, where's the variable we're solving for is y. So I need to find y. It's right here. And I want to identify the operations that are around the variable. So it's on the left-hand side. So what's happening around y? Well, y is, for one thing, it has a plus 1 here. But look where y is. It's inside parentheses, right? So parentheses is what part of SADMAP? Is at the beginning or at the end? And so should I even deal with that 1 right now? No. What else is by the y? Well, the whole parentheses is being multiplied by a. Okay, so before I could even go inside the parentheses, I have to deal with this multiplied by a. So since it's being multiplied by a, I have to do the opposite, which is divide by a. So a divided by a on the left side, which means I have to do the same thing on the right. So b divided by a. So the left side becomes y plus 1 is equal to b over a. Now I could put parentheses back here, but there isn't anything else to keep the parentheses or keep the numbers away from the parentheses, so I'm just going to take those away. And then I ask myself, oh look, there's just a plus 1 by the y. So what's the opposite of plus 1? Minus 1. So we got y is equal to b over a all minus 1. And that's your answer, okay? So I'm going to box it. That's how you do numbers 1 and 2. I don't know what formula this is. This is just a random formula, but that's how you would manipulate the letters. Okay? So are we doing really any math today in the sense of, are we like calculating numbers or doing any sort of calculations, computations? No. All we're doing is moving numbers, right? By using inverse operations. Bless you. Okay, so why don't you take a moment to tell the ones about number 1. I'm going to rewind this, okay? And then once... Okay, continuing on, number 3. Okay, it says P is equal to 2a plus 3b plus 4c. Okay, write this problem down and turn to your neighbor and tell him what side of the equation is c on. That's what we're focusing on. Left or right side? Go. Okay, what side is it on? Right side, right? So, if it's on the right-hand side, let's look around it. There's a plus 4 that's being multiplied with c. You all see the positive 4 being multiplied with c. And then what else is, there's also 2a being added to c and 3b being added to c. Okay, so let's use SADMAP. Are there any subtraction signs by the c? No. Any addition signs by the c? Yeah, what's being added to the c? Okay, good. So let's work that out. Let's first thing, let's subtract one of those. Let's subtract 3b first. And you could do that all at one shot, or you can just do it a step at a time. So I just subtracted 3b. What else can I subtract on both sides? We just subtracted 3b on both sides. What else is being added to c that I should subtract? 2a. Good. So we're going to subtract 2a on both sides. So we got p minus 3b minus 2a is equal to 4c. Okay? Next. Are there any more addition signs that we could deal with? No. Are there any division? Is there anything being divided from c? No. Is there anything being multiplied from by c? Yes. Yeah. What's being multiplied? 4, right? So what's the opposite of multiply by 4? Divide by 4. So we want to now divide both sides by 4. So we got, it looks like a big complicated problem, but you don't have to multiply or simplify anything here because these are all independent terms and all that's equal to c. What's one last step you can do here? Flip it using which property? The symmetric property. Good. So now we're going to do that. So c is equal to p minus 3b minus 2a all over 4. Okay? I want to see your whiteboard, so you're going to show me in 10 seconds. You're going to put your whiteboards up. I just want to make sure you got this, okay? Number 4. We got a plus 2b is equal to, or a plus 2b times y is equal to 2x. What variable are we trying to solve for here, everyone? Which one? A. What side of the equation is a in? Left-hand side, right? So, if that's the case, what's around the a that we need to worry about? What are you noticing that's going to kind of conflict with what we're working with? Parentheses, right? Sad mep. When does the p happen, or the parentheses at the end? So we're going to try to do any subtracting of 2b? No. What should we do before that? Turn to your neighbor and describe what you would do first before. Okay, raise your hand. Someone, let me know. Janessa.
You divide 2x by a plus 2b and y.
Nope. Okay, let's go slowly. Are there any subtraction signs by the a? Yes or no? No. Okay, just always do sad map whenever in doubt. Are there any addition signs by the 2 or by the a? Yes, good. But where's the addition sign? Inside the parentheses. When do parentheses get worked out in sad mep? At the end, right? Okay, so can we touch that addition sign right now? No. Okay, good. Let's keep going. Are there any division signs on the side on the left side of the equation? No. Are there any multiply signs on the left side of the equation? Yes or no? Yeah, what's being multiplied on the left-hand side? The what?
Y.
2b. Well, 2b is being multiplied, but what's wrong with 2b? What? Parentheses. Good. What else is being multiplied on the left-hand side?
Y.
Y. Is that inside the parentheses?
No.
No. So can I do the opposite of multiplying by y? What's the opposite of multiply by y? Divide by y. Okay, good. So it's really important that you do that correctly because students always mess this up. So divide both sides by y. So all we're getting is a plus 2b is equal to 2x over y. Okay? Now, there's nothing else on the left-hand side, so do I need to keep these parentheses that are there? If they're by themselves already? Do we need to keep the parentheses? No. Okay, now, let's keep going here. Start at the beginning. Now the parentheses have gone away. We just took away the parentheses. So start at the beginning. Are there any subtraction signs again? No. Addition signs?
Yep.
What's being added to a?
2b.
What's the opposite of adding 2b?
Negative.
Subtract 2b. Okay, good. So we're going to subtract 2b. Finish up my problem for me, please. Show me what my answer is. Go. 2x over y minus 2b becomes a is equal to 2x over y minus 2b, and that's it. That's your answer. Okay? Did you get that? Some of you are really close. You just have to fix a little bit. Okay? Any questions on number 4 before I take it away? Questions on 4? Okay, continuing. Number 5. Do this one by yourself. Go. On number 5, what's the variable I'm solving for? What's the letter?
T.
Is it on the left or right side?
Right.
Okay, good. So if it's on the right, looking here, Are there any, just focusing on the right side, are there any subtraction signs being subtracted from t? Addition sign, anything being added to t? Good, anything being divided by t? No, is there anything being multiplied to t or by t? Yeah, what's being multiplied by t? I and r. So what's the opposite of multiplying by I and r? Dividing by? Good, again, what's the opposite of multiplying by I and r? Good, so watch what I'm going to do. I'm going to divide by, how much? I and r. Whatever I do to one side, I do to the other, right? Okay, left side, p over I and r is p over I and r. Oh boy, went too fast there. Okay, and then the right side's t. What should I do at the end? Symmetric property, right? Mm-hmm. So p over I and r. Some of you got it right. Raise your hand if you got it right. Good job. Raise your hand if you're really close. You just need to fix a little bit. Okay, good. Raise your hand if you made a silly mistake. Okay. You all understand how to do this, right? Are you getting it? Is it making a little more sense? Yes or no? Okay, good. Keep going. Number 6 by yourself. Go. Last one. On this example, we need to do the opposite of subtract 6, which is, what's the opposite of subtract 6 again, Damien?
Add 6.
Good, add 6, okay? Oh, I'm sorry, I'm showing something here. Okay, so we got y plus 6 is equal to 5x times, or 5 times x, okay? Right now, just look at what we're doing. Okay, we added 6. Now, look at the x. What's by the x? Okay, what's the 5 doing? Is it being, are there any subtraction signs by the x anymore? Addition signs? Division signs? Multiply signs?
Yep.
What's being multiplied with x?
5.
What's the opposite of multiply by 5?
Divide.
Divide by 5. Never a trick question. You just got to do the opposite, right? And that's it. And then we're going to do symmetric property, so x is equal to y plus 6 over 5. Okay? Does that make sense? Okay, I'm going to leave that one up there in case anyone didn't write it down correctly. Let's put these in your notes. Okay? And that concludes the lesson.